Alright, good day, grade 9. So we are busy with numbers. We are continuing. 4.1, they ask you write 56, 84 and 104 as a product of their prime factors. Show all your working. Alright, so when they ask you to show all your working, that basically means, that part right there, it basically means we need to do either a ladder method or the factor 3 method. Okay, so however I didn't do that, but I did show now all of this. Alright, so on the screen you will see they have written 56 as a prime as a product of its prime factors. So now it will be 2 to the power of 3, which equals to 9, and 9 times 7 is equal to 56. Then 84 is 2 to the power of 2 times 3 times 7. I hope you all got that right. And then 104 is equal to 2 to the power of 3 times 13. Now they ask you give the highest common factor of 56, 84 and 104. And we actually looked in the previous lesson, we looked at a method how we can do that. And I told you, we look at what? When the numbers are prime factorized, we look at the common prime factors. And then, although it says highest common factor, we use the one with the lowest exponent. So therefore, so I'm going to write my answer right here, and I would write in the following way. So I would write HCF. Let's see if I can use another piece of... Alright, so HCF of 56, 84 and 104 will be, what is the same? 2, and then what is the lowest exponent? To the power of 2. Now I simplify. 2 to the power of 2 means 2 times 2 is equal to 4. Okay, so if you got that right, that's a correct mark like that. Just did it like Nike. Alright, so write 12 and 18 each as a product of their prime factors. Who wants to give me that answer? Raise your hand. Anyone? Have you done that? I'll give you a second to do that quickly. Alright. Only one hand. Any other hands who want to take a try? So let's do this together. Okay, so what we're going to do, we're going to write down 12. We're going to see 12 divided by the first prime number is 2, and then 12 times 2 is equal to 6. 6 I can divide by 2 is equal to 3, and then 3, and then I end there with my 1. So 12 prime factors of 12 is equal to 2 to the power of 2 times 3. Okay. Now I continue. But am I done? Did I answer the whole question? No. What was the other part of the question? I should write 18 as a product of its prime factors as well. Now I write prime factors of 18, and I say 18 prime factors. I'm quickly going to do it. So it's going to be 18. I write the number there. I say 18 can be divided by 2. 18 divided by 2 is equal to 9. Well done. And then 2 can't go into 9. Alright, but 3 can, so I write down a 3 in 3 times, and then I have 3 there and 1 there, and then I end off. So now I'm going to say, therefore, 2 times 3 to the power of 2. Question number 5.2. Hence, give the lowest common multiple of 12 and 18. In example, the LCM. Now remember, when we looked at the HCF, what did we use? We use only the common prime factors, and what else? What else did we use? The lowest exponent. Now by this, there's a quick method that I can tell you. So if we talk about the LCM, and you can make a note for yourself there. If we are talking about the LCM, and we are going to look at the example of 12 and 18, I'm going to use all my prime numbers. All right. So if there was there's 2 and 3, so it happened to be the same. But I'm going to use all my prime numbers. And what does this L stand for? It stands for lowest. But what do you think I'm going to use? Highest exponent. So I'm going to say, therefore it's going to be, there's a 2 in both of them. Okay? The 2 to the power of 2, because that is the lowest exponent between 2 and 1. And then 3 to the power times the 3 to the power of 2. Because there is the 3 to the power of 2 and a 3 to the power of 1. What is the highest exponent? 3 to the power of 2. Now I simplify this answer right here and I say, alright, that's going to be 4 times with 9, and 4 times 9 is equal to, well done, 36. Okay? So that is how you determine your lowest common multiple. And why is this important to know this method? Because this method is going to be very usable once we work with bigger numbers. Alright? So try to get in the habit of using, I know you know the other method of which you were taught in grade 8, where you write out all the multiples of 12 and all the multiples of 18. But if you're working with very big numbers, then it can be a lot of numbers. So that's why we are working in maths. Maths is supposed to simplify life, and that's why we use shorter methods like this. Alright, so make a note for yourself. We use all the factors of all the numbers, alright, but we only use the highest exponent if there's common factors as well. Now they ask you, write 70 as a product of its prime factors, and hence find the LCM of 12, 18 and 70. Alright, so let's quickly do 70. I'm going to prime factorize 70. So I just write 70 divided by 2 is 35, and then can 2 go into 35? No. What is my next number? 3? 5 can go in there 7 times, and then 7, and then I'm left with 1 right there. So what is my prime factors of, so now I'm going to write prime factors of 70. Okay, prime factors of 70 will therefore be equal to 2 times 5 times 7. Okay, so what did I say now? Once we want to determine the LCM, now it becomes really easy. All we have to do, we have to write our numbers here. So our numbers is going to be 12, 18 and 70. Who wants to help me with this? So what is going to be our numbers? 2 is there. 2 to the power of 2 times 3 to the power of 2 times, what am I missing? Times 5 times 7. Okay, and then we say, now we simplify 2 to the power of 2 is equal to 4. 4 times 9 times 5 times 7. Alright, so let's quickly do that multiplication. We can say 4 times 9 is equal to 36. Alright, so I'm going to write 36, and then I can write times 5 times 7. Alright, now anything times 5, do you remember that method that I show you? If you are timesing with 35, all we do, we half the number. So half of 36 is equal to 18, and then I add a 0 at the back, or I move the comma one place back. So that will be half of that, which is half of 36 is 18. So it becomes 180 times 7, and then 180 times 7. So 180 times 2 is equal to 360. 360 times 2, that's 4. So that is 720. And then 720 times 2 is 1060. Alright, and then we subtract our 180. What is our final answer? Give me that answer. $1,260. Alright, so what I did now, I said times 7. How can I quickly times with 7? I can say 1,200. Alright, let me just pause. Continuing at question number 6, they ask you write the following numbers in powers of prime factors. So all we have to do there, we have to prime factorize basically. Can anyone help me? Prime factors of 720. So I'm just going to fill in the answer here. Yes, my dear, what's your name? Linko. Okay, Liko. So tell me, Liko, what is your answer? 2 to the power of 4 times 3 to the power of 2 times 5. Do we agree with that? Yes, well done with that. Anyone wants to help me out with 216 as it's prime factorized? Yes. Alright, you can go check on your calculator. If you have a calculator like mine, you always say, this is a very old calculator. It was when I was with the dinosaurs. That time when I was born, this calculator came to existence. Alright, so let's see, 2 times 2 times 2 times 2, that's 4 times 3 times 3 times 5 is equal to 720. So that's correct. Okay, that's 720, 216. Anyone wants to take a chance? Yes, I see your hand is up, my boy. What's your name? Yeah. Yes, 720. 216, sorry. 2 to the power of 3 times to the power of 2. 3 to the power of 3. Is that correct? Okay, so that means 8 times 27. Right? 8 times 27 is equal to 216. Yes, that's correct. Alright, use the factors to find the values of the following. Now what we should now do the following. So I'm going to use this. What is the prime factors of this? So I'm going to rewrite this whole thing as 2 to the power of 4 times 3 to the power of 2 times 5 over 5. Now what we can do, because it's division, we can simply say that and that cancels out. Okay, now actually an interesting thing, there is a rule that says once we have what do we call this, a square root, there's a rule that says in a square root there's actually a 2 standing outside. Alright, so this is actually laws of exponents, which will be our next topic. So laws of exponents says I can divide the exponent by 2 and by 2. Alright, so let's check. I'm quickly going to shift that to the other side. Where's my selector? Come now, selector. Alright, so I'm going to select this quickly. Alright, doesn't want to work with me now. Come now, baby, this is not how we practiced it. You see, it's Valentine's Day and now she's being all difficult, this laptop of mine. Alright, so what are you supposed to do here? We cancelled out already that thing, so it's going to be, I'm going to write on this side quickly. Let's see where I can find some space. So 720, I already cancelled out that 5, so I'm going to leave that like that. So it's going to be 2 to the power of 4 times 3 to the power of 2, and then I have over 1. Okay, so what to simplify, I want to get rid of my square root, so that's going to be 2 to the power of 4 divided by 2 times with 3 to the power of 2 divided by 2, and then I simplify that number. Wow, I'm just gonna kill this quickly. You see, I don't struggle with my erasers like you guys. Easy erasers. Okay, so what I say now, this is therefore going to be 2 to the power of 2. I take it out of my square root now, and then it's going to be 3 to the power of 1, and then it's equal to 4 times 3, which equals to 12. Okay, so the answer is 12. Now I'm just going to see if I did calculate that correct. Please type in this in your calculator, 720 divided by 5, and then see if you get 12.